Have you ever wondered, where is creativity? Is creativity in your heart? Is creativity anywhere else in your body? Or is creativity in your brain? The answer is, it is in your brain. But within the brain, where is creativity? Creativity is stored at the synaptic joints of your brain. Now imagine human brain, an adult brain. An adult brain has roughly 100 billion neurons. Now 100 billion is quite a colossal number. As a matter of fact, these are similar to the number of stars which might be there out there in the entire known universe. 100 billion neurons. Now these neurons talk to each other through what we call as a neurochemical joint called a synaptic joint. So every neuron has an axon and a dendrite. An axon and the dendrite are two ends of a neuron. And when an axon and a dendrite meet, there is an exchange of chemicals that happens and maybe a bit of spark that happens, and that is where ideas are born. Now, you have a lot of thoughts. As you are listening to this particular video right now, as you're watching this video, these neurosynaptic joints are already happening in your brain. But they are momentary. They happen, then they're off. They happen, then they're off. But if they keep happening again and again, is when these patterns start forming, and that is where you tend to retain the information which I'm giving to you right now. And the classic saying that goes in the neurological space is that the neurons that fire together are the neurons that wire together. So if you want to wire the neurons and make it into some sort of a memory, you need to have those neurons talking to each other. So that's a basic element of where the ideas are born. Now, imagine what happens to these neural networks as the child grows. Now, this is a very fascinating slide. Look at this slide very, very carefully. What you see on the slide here on the screen is the evolution of human brain in terms of synaptic joints. On the extreme left-hand side is the brain of a newborn child. As I move from the newborn to 1 month to 9 months to 2 years and the adult, what do you see? Take a close look at this slide and what do you see? The first thing that you would see is that the brain mapping of somebody who is 9 months old is not remarkably different from somebody who is an adult. Which means by the 9th month of a child, the number of synaptic joints which are formed in the child's brain are quite humongous. At 2 years, the density has gone up. And if I compare the 2-year slice with the adult slice, something remarkable is happening. As a matter of fact, the number of connections have come down as an adult. But the density or the size of the node has gone up. It has become dense. You can see those thick nodes in the adult brain, which means what? Which means that as you grow in age, you are forming fewer and fewer new connections. And whatever connections you have already established as a child or as an adult in those upbringing years, you try to reinforce these. And as a result, your learning gets hampered. So as a child, you will be tremendously curious. You will go out and ask questions. Have you seen children asking questions? Why do children ask so many questions? One answer is, of course, they don't know much. So they are quiz people and they quiz things around. But as an adult, do you know everything? Of course, you don't know everything, but you don't ask. And in a next module, I'll talk about why you don't ask what you should be asking. But just stay with this image for a moment. This is very fundamental, that you have to exercise new neural synaptic connections in your brain. What happens when you don't do that? What happens as you grow old and if your neurons are not being used effectively, what happens is you suffer from diseases like Alzheimer's and dementia. Now on your screen is a very fascinating image of two brains, a normal brain and a brain suffering from Alzheimer's. What is very clearly evident over here is that there are certain regions which are dead. Which means that if you have not been using your certain parts of the brain very effectively, over a period of time, they'll start atrophying. They'll start giving in. It's just like your left hand and the right hand. Now at the time of birth, I could have written with any hand. But I chose one hand over another hand. For example, I chose to write with my right hand. Now today, if I look at both the hands are exactly the same, but I can't write with my left hand. I have no fine motor skills in my left hand left anymore. And the reason is because my right hand is trained. Similarly, there is a very high possibility that out of the two halves of the brain, maybe you are training one half more severely than another, and as a result, the other half is absolutely giving away. Can that be reversed? It can be. And that is where we have this very amazing science experiment done. Now imagine there are a bunch of people who are suffering from advanced stages of dementia, and I break them into three cohorts, A, B, and C. In each of these three cohorts, I measure their neural activities after administering certain exercises. The first cohort is sent for morning walk. They go out in the nature, they get fresh oxygen, maybe their neurons start firing up and things like that, and we measure what has been the neural activity at the end of the event. The second group has been given puzzles. They are given puzzles and they have to be at the puzzle for an extensive amount of time solving those puzzles. And the third group is sent to a museum where they're drawing a naked person's painting. Which of the three groups, A, B, or C, do you think has the highest improvement in neural synaptic joints? Take a moment to ponder on it. Most people give the answer as B, the ones which were given puzzle. But the correct answer is C. Of course, when you go out in the open and you do jogging, any sort of a physical exercise, your brain gets oxygenated, and which is very good. But it doesn't create new networks. Because you're doing the same thing which you have a routine of. Puzzles. Once again, when you're solving a puzzle, which part of the brain you're using extensively? Right or the left? You're most likely using the left brain. So most puzzles are left brain puzzles. Okay? They're analytical, they're mathematical, rigorous, sequential, logical. And most of us are actually using our left brain quite a bit anyways on a day-to-day basis. But when you're going to an art school and you're actually drawing art, suddenly there is a whole faculty of your right brain which you haven't used since many years now, and there is a bulb that lights up there. And these networks starts firing up and new networks starts building up, and that is where we have seen a substantial improvement. So what's the hint? The hint is that if you have to be more creative, the first and the foremost thing that you must do is to try to use both half of your brain, the left and the right half. Now, what does the left and the right half entail? You see, the left half of the brain is extremely endowed with the abilities of logic, facts, linear thinking, sequencing. The right half of the brain, on the other hand, is endowed with the abilities of rhythm, art, etc. And what happens when these two brains are talking to each other a lot more? What happens is you become more creative, because creativity is not a right brain phenomena or a left brain phenomena. Creativity is a phenomena of what we call as a prefrontal cortex. This is where the house of creativity is, not here or here, it is here, because that is where both these things come together. And these two things come together when scientists have artistic hobbies and artists pursue science. And that's a big reason why some of the most famous mathematicians in the world have also been philosophers. So if you are too deep into perhaps using left brain, here is a chance for you to start using a bit of right brain. And in the next module, I'll tease you onto how some of these things can be developed. I hope you now understand where the seed or the house of creativity. Thank you.